Artificial intelligence is becoming a powerful capability across business, government, research, education, healthcare, and everyday life. It can analyze enormous volumes of information, automate work, generate content, identify patterns, and support decisions. But capability alone does not guarantee accuracy, fairness, safety, or trustworthy outcomes. In this video, we will examine what artificial intelligence performs well, where it can fail, and why governance and human oversight must accompany its growing capabilities. This is Responsible AI: Capabilities, Risks, Governance, and Human Oversight. Part 1. Video 3 of AI as a Transformative Technology. Artificial intelligence can analyze data, automate processes, generate content, and predict possible outcomes. These capabilities can improve productivity, increase consistency, accelerate research, and help people undertake complex work more effectively. However, an AI system can also produce an answer that sounds clear, polished, and convincing, while still being incomplete, biased, outdated, or simply wrong. This creates an important distinction. Technical capability is not the same as trustworthy performance. Responsible AI provides the bridge between the two. It introduces the principles, safeguards, governance structures, and human controls needed to capture AI's benefits, while reducing risks to individuals, organizations, society, and the environment. AI systems perform particularly well when a task has certain characteristics. First, the work involves large volumes of data that exceed normal human processing capacity. Second, the data contains repeatable patterns that a system can learn to recognize. Third, the objective is clearly defined, so the system has a specific task or outcome against which its performance can be assessed. And fourth, the work involves computationally intensive operations that machines can perform faster and more consistently than people. These conditions allow AI to apply its principal strengths: speed, scale, computation, memory, pattern recognition, and continuous processing. One of AI's greatest strengths is its ability to analyze data at scale. AI can process large and complex datasets much faster than people. It can detect correlations, find anomalies, reveal trends, and recognize patterns that may not be apparent through manual analysis. These capabilities support many practical applications. In financial services, AI can help detect unusual transactions that may indicate fraud. In healthcare, it can assist with the analysis of medical images. In business and logistics, it can support demand forecasting and customer behavior analysis. And in manufacturing, it can examine equipment and sensor data to identify signs of possible failure before a breakdown occurs. AI does not remove the need for expertise. It expands the amount of information that qualified people can examine when making decisions. AI is also well suited to routine and structured activities. It can assist with data entry, document classification, report preparation, ticket routing, quality inspection, and transaction processing. These activities often follow repeatable rules and involve large numbers of similar transactions. Automation can reduce processing time and improve consistency across the workflow. But the objective should not simply be to remove people from the process. The more valuable opportunity is to reduce the burden of repetitive work, allowing employees to devote more time to analysis, creativity, problem solving, client interaction, and professional judgment. The outcome should therefore be faster processing, greater consistency, and more time for work that genuinely requires human capability. Generative AI can create and transform many different forms of content. It can draft and summarize text, write software code, create images, translate languages, reorganize documents, and help develop presentations for different audiences. These capabilities can accelerate knowledge work and make sophisticated computing tools available through ordinary language. Machine learning systems can also support prediction and recommendation. They can estimate probabilities, forecast future events, rank alternatives, and recommend possible actions. But prediction is not certainty, and recommendation is not responsibility. AI can expand the evidence available to a decision maker, but its outputs still require validation. Human judgment must be retained when decisions involve significant legal, medical, financial, ethical, or social consequences. AI-enabled systems can operate continuously and apply defined processes consistently at scale. Subject to infrastructure availability, maintenance, and system reliability, they can monitor networks, industrial equipment, infrastructure, transactions, and customer interactions over extended periods. This can improve service availability, support early warning systems, and strengthen operational reliability. AI-enabled machines and robots can also undertake work in environments that present serious physical risks to people. These may include areas with radiation, extreme temperatures, dangerous machinery, or disaster conditions. Drones and robotic systems can inspect, measure, transport, or perform controlled operations while reducing direct human exposure. Here, the purpose of automation is not merely greater efficiency, it is also the protection of human life and safety. The most valuable role of artificial intelligence is often augmentation rather than substitution. AI contributes speed, computation, memory, pattern recognition, and continuous monitoring. Humans contribute contextual understanding, creativity, empathy, ethical reasoning, judgment, and accountability. These capabilities are different but complementary. AI can identify statistical relationships that people may overlook. People can recognize social, cultural, ethical, and situational factors that an AI system may fail to understand. The best outcomes emerge when work is deliberately designed so that humans and AI each perform the tasks for which they are best suited. People provide purpose, direction, interpretation, supervision, and accountability. AI provides scale, speed, analytical capacity, and computational support. The future is therefore not simply humans versus machines. It is humans working responsibly with intelligent systems, because the best outcomes combine both. Artificial intelligence can produce impressive results, but every output depends on the information and conditions surrounding the system. AI outputs are influenced by training data, system design, user prompts, available context, and operating constraints. If the training data is incomplete, outdated, unrepresentative, or biased, the resulting output may also be inaccurate or unfair. Weak system design can introduce flawed assumptions. An unclear or leading prompt can direct the model toward an unreliable answer. Missing context can prevent the system from recognizing important facts or circumstances. And operating constraints, such as limited time, computing capacity, access to information, or organizational rules, can further affect performance. An AI system cannot reliably compensate for important knowledge that it was never trained on, or that was not provided during use. This leads to a fundamental principle. The quality of an AI output depends heavily on the quality of its inputs, instructions, design, and context. Missing, outdated, or biased inputs can produce unreliable results. Generative AI can produce information that appears fluent, confident, and authoritative even when it is incorrect. These errors are commonly called hallucinations. An AI system may fabricate facts, references, explanations, calculations, quotations, or sources. The answer may sound convincing because the language is polished and logically structured, but confidence of presentation is not evidence of accuracy. This makes hallucinations particularly difficult for inexperienced users to detect. A fabricated reference may look genuine. An incorrect calculation may be presented without hesitation. A false explanation may contain enough accurate language to appear trustworthy. AI-generated output should therefore not automatically be treated as established fact. It should initially be regarded as a draft, a recommendation, or a hypothesis. The need for verification becomes especially important in healthcare, law, finance, engineering, scientific research, and public policy. In these fields, an inaccurate answer can cause serious financial, legal, professional, or human consequences. The message is simple. Do not confuse fluent language with verified knowledge. Treat AI output critically and verify before use. Artificial intelligence can process language, generate emotional expressions, and imitate human conversation. But it does not understand the world in the same way that a person does. Current AI systems have no lived experience. They have no consciousness. They do not experience relationships, loss, culture, responsibility, fear, hope, or personal consequence. They may generate words that sound compassionate, but they do not feel compassion. They may describe an ethical problem, but they do not carry moral responsibility for the result. They may recognize patterns associated with emotion, but they do not experience empathy. This distinction matters when decisions require cultural sensitivity, negotiation, moral reasoning, or an understanding of personal circumstances. A system may process the information presented to it, but it may fail to understand the human meaning behind that information. AI can assist people by organizing evidence, identifying patterns, and generating alternatives. But decisions involving dignity, fairness, personal welfare, or social consequence require human understanding and judgment. Simulated emotion is not compassion, and computational intelligence is not the same as human experience. Artificial intelligence is often perceived as objective, but an automated system can learn, reproduce, and amplify historical inequalities contained in its data and design. Bias can enter at many points. It can enter through the training data. It can arise during data labeling. It can be introduced through model design, the choice of variables, or the assumptions built into a system. It can also emerge through the context in which the system is deployed, the behavior of users, and the feedback loops created after deployment. Once embedded in an automated process, bias can be repeated rapidly and at scale. A system may disadvantage certain groups while still appearing neutral or technically consistent. Fairness, therefore, requires more than removing a few sensitive characteristics from the data. Organizations must examine outcomes across different populations. They must ask who benefits, who may be harmed, and who may be excluded. Human review is essential for detecting disparities, questioning assumptions, and correcting unfair results. Teams may need to improve datasets, change variables, redesign models, adjust policies, or restrict particular uses. Bias is not solved by assuming that technology is neutral. It requires continuous examination, correction, and accountability. An AI system does not operate in a fixed world. Customer behavior changes, language evolves, markets shift. New regulations are introduced, technologies develop, and patterns in real-world data change over time. A model may perform well during testing because it reflects the conditions that existed when it was developed. But as the surrounding environment changes, the model's assumptions may become less accurate. This gradual decline in performance is known as model drift. A system that worked well yesterday may produce weaker or misleading results tomorrow. The problem may not be immediately visible. The model may continue generating outputs with the same confidence and speed even as its accuracy declines. Organizations must therefore monitor deployed systems continuously. They should compare predictions with actual outcomes, detect changing error rates, examine performance across different groups, and identify unexpected consequences. Models may need to be updated, retrained, restricted, or withdrawn. Deployment is not the end of the AI development process, it is the beginning of continuous performance management. AI systems may process large volumes of personal, confidential, copyrighted, commercially sensitive, or security-critical information. This creates significant privacy and security risks. Sensitive data may be exposed through leakage or unintended disclosure. Unauthorized users may gain access to systems or information. AI may be used for excessive surveillance or monitoring. Malicious instructions may attempt to manipulate the system through prompt injection. Attackers may try to alter model behavior, extract protected information, or interfere with connected tools and applications. AI systems can also become targets for cyber attacks, malware, and data theft. These risks increase when AI agents are connected to enterprise systems, databases, communication platforms, or external tools. Security cannot therefore be added only after an AI system has been deployed. It must be built into the entire lifecycle. Organizations need access controls, encryption, data minimization, secure system design, monitoring, audit logs, retention policies, and incident response procedures. They must also decide what information the AI system should never receive, retain, reveal, or act upon. Responsible AI requires privacy and security by design, not privacy and security as an afterthought. The visible cost of artificial intelligence is often the model subscription, software license, or technology contract. But this is only the beginning. Organizations may need to invest in data preparation, cloud infrastructure, integration with existing systems, cybersecurity, and technical support. They may also require workforce training, governance structures, legal review, performance monitoring, model maintenance, and organizational change. These hidden costs can be much larger than the initial software expense. Data may need to be cleaned, classified, protected, and updated. Existing workflows may need to be redesigned. Employees may need new skills and responsibilities. Legal, compliance, security, and risk teams may need to become involved, and the system must continue to be monitored and maintained after deployment. An AI project should therefore be selected because it addresses a legitimate problem and can create measurable value, not simply because the technology is available. Poorly selected projects may consume money, time, data, and managerial attention without delivering meaningful results. The true cost of AI includes the full system required to make it useful, secure, reliable, and responsible. Artificial intelligence will change both the nature of work and the skills required to perform it. Automation may reduce demand for some routine and repetitive roles. At the same time, it can create new technical, supervisory, analytical, and governance responsibilities. People will be needed to design systems, supervise AI outputs, interpret results, manage risk, investigate incidents, and ensure accountability. However, this transition will not automatically benefit everyone. Workers may be displaced, skill gaps may widen, some groups may have less access to training and opportunity, and inequality may increase if organizations and governments do not support inclusive adoption. There is another risk. Over-reliance on AI can gradually weaken human expertise. If people repeatedly accept recommendations without understanding or questioning them, they may lose analytical, professional, or decision-making skills. The response should not be to resist every form of automation. It should be to invest in retraining, continuous learning, inclusive access, and critical thinking. People must learn when to use AI, how to evaluate its output, and when to challenge or reject its recommendations. The objective is a workforce transition from routine execution towards supervision, analysis, creativity, governance, judgment, and human interaction. An artificial intelligence system cannot accept legal responsibility. It cannot accept professional responsibility. And it cannot accept moral responsibility. AI can generate recommendations, coordinate workflows, use tools, and execute actions. But it cannot be held accountable in the same way that a person, professional, institution, or governing body can. People and organizations remain responsible for how AI systems are designed, deployed, monitored, and used. They remain responsible for the consequences. This becomes increasingly important as AI agents gain greater autonomy. An agent may access information, communicate with other systems, select tools, and carry out multi-step tasks with less direct supervision. But greater autonomy does not remove human responsibility. It increases the need for stronger governance. Important actions may require human review and approval. People must be able to intervene, override, restrict, or stop the system. Records should document decisions, approvals, model changes, incidents, and corrective actions. Responsibility must be assigned clearly across leaders, developers, vendors, users, risk teams, and oversight functions. AI may assist with decisions, it may even execute approved actions, but accountability stays human, and greater AI autonomy demands stronger human oversight. Artificial intelligence can create significant value, but that value must be pursued responsibly. Responsible AI is the disciplined design, development, deployment, and use of artificial intelligence in ways that maximize beneficial outcomes while reducing foreseeable harm. It translates ethical values, legal requirements, and organizational commitments into practical controls. Responsible AI is therefore not simply a declaration of good intentions. It requires governance structures, it requires technical safeguards, it requires clear documentation, rigorous testing, human oversight, risk assessment, continuous monitoring, and accountability. These controls help organizations identify what an AI system is intended to do, what it should not do, who may be affected, and who remains responsible for its outcomes. Responsible AI must consider more than the technical performance of a model. It must consider the people who use the system, the individuals and communities affected by it, the organizational processes surrounding it, and the wider social and environmental consequences. The objective is not to prevent innovation. It is to ensure that innovation produces useful, safe, fair, and trustworthy outcomes. Responsible AI connects capability with responsibility and technical performance with human values. Responsible AI frameworks use different terminology, but the major frameworks converge around a common set of principles. The first 5 principles focus directly on protecting people, strengthening trust, and maintaining meaningful human control. The first principle is fairness and non-discrimination. AI systems should not unfairly disadvantage individuals or communities. Organizations must examine whether data is biased, whether error rates differ across groups, and whether the system creates exclusion, stereotyping, or discriminatory outcomes. Fairness is not achieved simply by claiming that a system treats everyone in the same way. The real question is whether its outcomes are equitable, and whether particular groups experience greater harm or fewer benefits. The second principle is reliability, robustness, and safety. An AI system should perform consistently under normal conditions, under unusual conditions, and under foreseeable misuse. It should be tested for errors, unexpected inputs, system failures, cyber attacks, and harmful behavior. Organizations should also have mechanisms to correct, restrict, override, or withdraw the system when its risks become unacceptable. The third principle is transparency and explainability. People should know when they are interacting with artificial intelligence. They should understand the system's intended purpose, its major capabilities, its known limitations, and the circumstances in which it should or should not be used. When an AI system affects an individual, the organization should be able to provide a meaningful explanation of the information, factors, or processes that contributed to the outcome. People should also have an opportunity to question or challenge decisions that affect them. Transparency requires documentation. This may include the system's purpose, its data sources, known limitations, performance measures, updates, responsible owners, and permitted or prohibited uses. The fourth principle is privacy and security. AI systems should respect privacy and protect sensitive information. Data should be collected only when it is necessary, and used in ways that are proportionate, lawful, secure, and transparent. Safeguards may include data minimization, access controls, consent where appropriate, encryption, retention policies, and protection against unauthorized use or disclosure. Privacy and security must be built into the system from the beginning, not added after deployment. The fifth principle is human-centered design and oversight. AI should support human well-being, dignity, and agency. People must retain meaningful authority over high-impact decisions. They must also be able to intervene when a system behaves unexpectedly. Human oversight may take several forms. In a human-in-the-loop system, a person reviews an AI output before action is taken. In a human-on-the-loop system, a person supervises an automated process and can intervene when necessary. And in a human-in-command system, people retain ultimate authority, governance, and accountability. The level of oversight will vary according to the task and the seriousness of the possible consequences. But the central principle remains unchanged. Technology should support people, not remove their rights, agency, or responsibility. Trust begins with protecting people. The next 5 principles extend responsible AI into organizational accountability, social inclusion, proportional governance, environmental responsibility, and human capability. The 6th principle is accountability and traceability. Organizations and individuals remain accountable for the AI systems they create, purchase, deploy, or use. Responsibilities should be clearly assigned across leaders, developers, vendors, users, risk teams, legal teams, and oversight functions. Organizations should also maintain records that allow important actions to be traced. These records may include data sources, model versions, decisions, approvals, incidents, system changes, and corrective actions. Traceability helps an organization understand what happened, why it happened, and who was responsible for responding. The 7th principle is inclusiveness and accessibility. AI should be designed to benefit diverse populations. This includes people with disabilities, underrepresented communities, speakers of different languages, and individuals from different social and economic backgrounds. Organizations should ask whether different groups can access the system, whether they can understand and use it, and whether its benefits are distributed fairly. A technically effective system may still be irresponsible if it excludes people or widens existing inequalities. The 8th principle is proportionality and prevention of harm. The level of AI autonomy, testing, monitoring, and control should reflect the seriousness of the possible harm. A low-risk writing assistant should not require the same governance as a medical diagnosis system. A credit decision, an autonomous vehicle, or a platform controlling critical infrastructure. Higher risk applications require stronger testing, greater transparency, more intensive monitoring, and more direct human oversight. Responsible adoption also requires organizations to ask whether AI is genuinely necessary for the intended objective. Technology should be used only to the extent required for a legitimate purpose and supported by an appropriate assessment of risk. The 9th principle is sustainability. Artificial intelligence depends on computing infrastructure, energy, water, minerals, electronic equipment, and data centers. Responsible adoption should therefore consider energy consumption, carbon emissions, resource use, hardware life cycles, and environmental impact. A system should not be evaluated only by what it can produce. Organizations should also examine the resources it consumes and whether the resulting benefits justify those costs. The 10th principle is AI literacy. People need sufficient knowledge to understand what artificial intelligence can do, where it may fail, and when they should not rely on it. AI literacy includes understanding capabilities and limitations, verification practices, data privacy, bias, appropriate prompting, ethical use, security risks, organizational policies, and escalation procedures. Users do not need to become computer scientists, but they do need the knowledge and judgment required to use AI critically and responsibly. Without AI literacy, people may trust unreliable outputs, share information inappropriately, overlook bias, or use systems beyond their intended purpose. Responsible AI therefore depends not only on better technology, but also on informed people. Together, these 10 principles provide a foundation for trustworthy adoption. They help organizations protect individuals, maintain accountability, strengthen institutional trust, and align AI innovation with human and environmental well-being. The central message is clear: the level of control should reflect the level of risk. And as AI systems become more capable, the need for fairness, safety, transparency, oversight, and accountability becomes even more important. This section follows the paper's definition of responsible AI and its 10 consolidated principles. Responsible AI cannot be treated as a final compliance exercise. It must be embedded across the complete life cycle of an artificial intelligence system. Responsibility begins before development, continues through data preparation and model building, guides testing and deployment, and remains essential after the system enters real-world use. Each stage introduces different decisions, risks, and responsibilities. Before development, the organization must establish why the system is needed, who may be affected, and what forms of human oversight are appropriate. During data and model development, teams must examine quality, representativeness, privacy, intellectual property, bias, accuracy, robustness, and security. Before deployment, the system must be tested under realistic conditions. Users need clear guidance. Accountability must be assigned, and people must be able to intervene, override, or stop the system when necessary. After deployment, the organization must continue monitoring performance, bias, drift, incidents, security, and wider impact. Governance and accountability therefore form a continuous outer layer around the entire AI lifecycle. They connect every stage. They ensure that decisions made early in development are carried forward into real-world operation. And they help organizations respond when conditions, risks, or system behavior change. Responsible AI is continuous, not a final compliance check. Responsible AI begins before the first dataset is prepared or the first model is selected. The organization must first define the legitimate purpose of the proposed system. What problem is it intended to solve? What benefit is expected? And how will success be measured? The next question is equally important. Is artificial intelligence actually necessary? Some problems may be solved more effectively through simpler software, improved processes, better data management, or clearer human decision-making. AI should not be adopted merely because it is fashionable or technically available. Organizations must also identify the stakeholders who may be affected. These may include users, employees, customers, citizens, communities, regulators, or groups who may never interact directly with the system but may still experience its consequences. Possible harms should then be assessed. Could the system create unfair treatment? Could it expose sensitive information? Could it exclude particular groups? Could an incorrect recommendation create legal, financial, medical, social, or environmental harm? Organizations should establish acceptable use boundaries before development begins. They should define what the system is permitted to do, what it must not do, and which situations require escalation to a qualified person. Legal and regulatory requirements must also be reviewed at this stage. These may involve privacy, intellectual property, employment, consumer protection, safety, professional standards, or sector-specific obligations. Finally, the organization must decide the appropriate level of human oversight. Will a person review every important output before action is taken? Will a person supervise an automated process and intervene when required? Or will people retain ultimate command over a system that performs some tasks autonomously? These questions are easier to address before development than after a system has already been built around weak assumptions. Responsible design begins with a legitimate purpose, a clear understanding of risk, and an explicit commitment to human responsibility. Once the purpose and boundaries have been established, responsibility must continue through data preparation, model development, testing, and deployment planning. The first priority is data quality and representativeness. Teams must examine whether the data is accurate, complete, current, and suitable for the intended task. They must also ask whether different populations, conditions, and real-world situations are represented adequately. A model trained on incomplete or unbalanced data may perform well for some groups and poorly for others. Privacy and intellectual property must be protected throughout development. Teams should understand where the data came from, whether it was obtained lawfully, what permissions apply, and whether confidential, copyrighted, or personal information is being used appropriately. Sources and assumptions should be documented. This creates a record of how the system was built, what limitations were known, and which decisions influenced its behavior. The system must then be tested for bias, accuracy, robustness, and security. Testing should not focus only on ideal examples. Teams should examine unusual inputs, incomplete information, changing conditions, system failures, misuse, and possible attacks. Clear performance thresholds should be established before deployment. Organizations must decide what level of accuracy is acceptable, what error rates are tolerable, and which failures require intervention or suspension. Testing must also occur under realistic conditions. A model that performs well in a controlled development environment may behave differently when exposed to real users, operational pressure, incomplete data, or changing circumstances. Before deployment, organizations should define escalation and fallback procedures. What happens when the system is uncertain? Who reviews disputed outputs? What alternative process is used when the AI system is unavailable? And who has the authority to override or stop it? Deployment approval should therefore be the result of a series of past checkpoints, not a single technical decision. Data quality, privacy, bias, accuracy, security, realistic testing, and human control must all be addressed before the system is released. No critical gate should be skipped. Deployment is not the end of responsible AI. It is the beginning of continuous real-world oversight. Organizations must monitor system performance over time. They should compare predictions and recommendations with actual outcomes, track error rates, and identify whether performance is declining. Bias and model drift must also be detected. A system may begin producing unequal outcomes or become less accurate as language, markets, regulations, technology, and user behavior change. Organizations need processes for reporting incidents. Users and employees should know how to raise concerns, how to report unexpected behavior, and where serious problems should be escalated. Human review must remain active. People should examine important decisions, challenge questionable outputs, and intervene when the system behaves outside its intended boundaries. User feedback is another essential source of information. People who interact with the system may identify confusion, exclusion, errors, or unintended consequences that were not discovered during testing. Security must also be updated continuously. New vulnerabilities, attacks, malicious prompts, and system dependencies may emerge after deployment. Periodic audits help determine whether the system remains accurate, lawful, secure, fair, and aligned with its original purpose. Changes should be documented. Organizations should maintain records of model updates, altered data, revised rules, incidents, approvals, and corrective actions. These records support traceability and accountability. Most importantly, an organization must be prepared to restrict or withdraw a system when risks cannot be controlled. A system should not remain in operation simply because time and money have already been invested in it. Human safety, rights, trust, and organizational responsibility must take priority. Responsible AI therefore requires a live operational capability. It combines people, processes, technology, education, policy, and governance. It monitors continuously, responds when conditions change, and stops the system when continued use is no longer responsible. Responsibility continues after deployment, and when risks cannot be controlled, the system must be withdrawn. This section follows the source paper's Lifecycle framework covering actions before development, during data and model development, before deployment, and after deployment. Responsible AI principles become useful only when they influence real decisions. Organizations need a practical way to evaluate an AI proposal before trusting it with information, recommendations, decisions, or actions. The source paper organizes this evaluation around 8 questions. The first 4 questions examine purpose, capability, risk, and data. The first question is purpose. What legitimate problem is the AI system intended to solve? Every AI initiative should begin with a clearly defined need. The organization should be able to explain the problem, the people affected, the expected benefit, and the outcome it hopes to improve. The purpose should be specific enough to guide design and evaluation. A vague objective, such as improving efficiency or becoming more innovative, is not sufficient on its own. The organization must identify the actual task or decision that AI will support. It should also ask whether the proposed use is legitimate and whether artificial intelligence is the most appropriate solution. A system should not be developed simply because AI is available or because competitors are adopting similar technology. A legitimate purpose provides direction. It establishes the basis for selecting data, measuring performance, assessing risk, and determining accountability. Without a clear purpose, an organization cannot reliably judge whether the system is useful or whether it should be deployed at all. The second question is capability. Is the system demonstrably capable of performing the task? An AI system should be evaluated on evidence, not on impressive demonstrations, marketing claims, or assumptions about what artificial intelligence can do. The organization must test whether the system can perform the intended task accurately and consistently. Testing should reflect the conditions in which the system will actually operate. A model may appear highly capable when given carefully prepared examples, but perform poorly when faced with incomplete information, unusual circumstances, changing conditions, or real users. Capability must therefore be demonstrated for the specific purpose and context. Organizations should define clear performance thresholds. They should determine what level of accuracy is required, which errors are acceptable, and which failures would create unacceptable consequences. They must also consider whether the system performs consistently across different groups, locations, situations, and periods of time. A model that performs well on average may still be unsuitable if its errors are concentrated among particular communities or high-risk cases. The question is not simply, can the AI produce an answer? The real question is, can it perform this task reliably enough for this intended use? The third question is risk. Who could be harmed, excluded, or disadvantaged? Every AI system affects people differently. Some may benefit directly, others may experience errors, exclusion, loss of opportunity, privacy intrusion, or unfair treatment. Organizations should identify the individuals, groups, and institutions that may be affected, including those who may not interact directly with the system. They must examine the seriousness and likelihood of possible harm. Could an incorrect result affect a person's health? Could it influence access to employment, credit, education, insurance, or public services? Could the system expose sensitive information? Could it reinforce historical discrimination? Could automation remove meaningful human review from an important decision? Risk assessment must consider both intended use and foreseeable misuse. It should examine what may happen when the system is wrong, when the information is incomplete, when users misunderstand its limitations, or when malicious actors attempt to manipulate it. The level of governance should reflect the level of risk. A low-risk tool used to draft internal text may require relatively simple controls. A system influencing medical care, financial decisions, legal outcomes, or critical infrastructure requires much stronger testing, monitoring, explanation, and human oversight. The fourth question is data. Is the data accurate, lawful, secure, and representative? AI systems depend heavily on the information used to develop and operate them. Poor quality data can produce poor quality outcomes. Teams must assess whether the data is accurate, complete, current, and relevant to the intended task. They must determine whether it represents the populations and conditions in which the system will be used. If important groups or circumstances are missing, the model may perform unevenly or create unfair outcomes. The organization must also establish whether the data was obtained and used lawfully. Privacy rights, consent, confidentiality, copyright, intellectual property, and contractual restrictions may all be relevant. Sensitive information must be protected against unauthorized access, reuse, disclosure, or manipulation. Data sources and assumptions should be documented. This allows the organization to understand where information came from, how it was prepared, what limitations are known, and how those limitations may affect the system. The first four questions therefore establish the foundation. What legitimate problem are we solving? Can the system actually perform the task? Who may benefit or be harmed? And is the supporting data accurate, lawful, secure, and representative? Before an organization trusts AI, it must be able to answer all four. The final four questions focus on oversight, transparency, accountability, and monitoring. Together, they determine how human responsibility will be maintained once the system is used. The fifth question is oversight. Which decisions require human approval? Not every AI output needs the same level of review. The appropriate level of oversight depends on the seriousness of the decision, the system's reliability, and the possible consequences of error. For low-risk activities, occasional supervision may be sufficient. For high-impact decisions, a qualified person may need to review the output before any action is taken. Organizations should identify which decisions can be automated, which require human confirmation, and which should remain entirely under human control. Human approval must be meaningful. A person should have sufficient information, authority, time, and expertise to question the system's recommendation. They must be able to reject the output, request further evidence, select an alternative, or stop the process. Human oversight should not become a ceremonial approval in which people routinely accept whatever the system recommends. The objective is to preserve judgment and control, particularly when decisions affect rights, safety, welfare, or opportunity. The sixth question is transparency. Do users understand the system and its limitations? People should know when artificial intelligence is being used. They should understand its intended purpose, the type of output it produces, and the degree of confidence that can reasonably be placed in that output. Users should also be informed about known limitations. They need to know when the system may produce errors, when additional verification is required, and when the task should be escalated to a human specialist. Transparency does not always require explaining every technical detail of a complex model, but it does require meaningful information. Users should understand enough to use the system appropriately, interpret its output, and recognize circumstances in which it may be unreliable. When AI affects an individual, that person may also need an explanation of the important factors that influence the outcome. They should have a way to question, challenge, or seek review of a consequential decision. Transparency supports informed use. It reduces over-reliance, helps people detect misuse, and strengthens trust when the system is operating as intended. The seventh question is accountability. Who is responsible for outcomes and corrective action? Responsibility must be assigned before the system is deployed. Leadership may be responsible for approving the purpose and level of risk. Developers may be responsible for technical design and testing. Data teams may be responsible for quality, legality, and security. Vendors may have obligations concerning model performance and updates. Users may be responsible for following guidance and verifying important outputs. Risk, legal, compliance, and oversight teams may be responsible for review and escalation. These responsibilities should be clearly defined. When an error or incident occurs, the organization should not have to begin by asking who owns the problem. Someone must have the authority to investigate, correct, restrict, or withdraw the system. Accountability also requires traceability. Organizations should maintain records of data sources, model versions, approvals, important decisions, incidents, changes, and corrective actions. An AI system cannot accept responsibility for the consequences of its output. Accountability remains with the people and institutions that design, deploy, supervise, and use it. The eighth question is monitoring. How will performance, bias, security, and impact be evaluated over time? An AI system may perform well when first deployed, but conditions do not remain static. Data patterns change, users behave in unexpected ways, new risks emerge, models drift, security threats develop, and the wider social impact may become visible only after the system has been used for some time. Organizations must therefore establish a monitoring plan before deployment. They should define what will be measured, how frequently the system will be reviewed, and which results will trigger investigation or intervention. Monitoring may include accuracy, error rates, performance across different groups, user complaints, security incidents, unexpected outputs, and changes in real-world outcomes. User feedback should be collected and examined. Periodic audits may be required. Models may need updating or retraining. Controls may need to be strengthened. and when risks cannot be reduced to an acceptable level, the system may need to be restricted or withdrawn. Monitoring turns responsible AI from a one-time assessment into an ongoing management process. Together, the 8 questions create a practical framework. Purpose asks why the system should exist. Capability asks whether it can perform the task. Risk asks who may be harmed or excluded. Data asks whether the information is suitable and responsibly used. Oversight identifies where human approval must remain. Transparency ensures that users understand the system and its limitations. Accountability establishes who owns outcomes and corrective action. And monitoring ensures that performance, bias, security, and impact continue to be evaluated over time. These questions should be asked before an organization trusts AI and revisited throughout the system's life cycle. Because trust is not created by capability alone. Trust is earned through evidence, transparency, human judgment, continuous monitoring, and clear accountability. This section follows the paper's 8-question practical responsible AI framework covering purpose, capability, risk, data, oversight, transparency, accountability, and monitoring. Artificial intelligence offers substantial capabilities. It can analyze information at scale, automate repetitive work, generate and transform content, support prediction, monitor systems continuously, and help people undertake complex tasks more effectively. But technical capability does not validate itself. An AI system may produce an answer that appears polished, coherent, and confident, while still being inaccurate, incomplete, biased, outdated, or unsupported. Its output must therefore be examined in relation to the quality of its data, the design of the system, the instructions it receives, the context available, and the conditions in which it is being used. The first key takeaway is clear. AI is powerful, but it is not self-validating. Capability demonstrates what a system may be able to do. Evidence, testing, and verification determine whether its output should be trusted. The second takeaway is that human oversight remains essential. Artificial intelligence can identify patterns, generate alternatives, estimate probabilities, and recommend possible actions. But it does not possess lived experience, moral responsibility, empathy, or a human understanding of consequences. People must therefore retain meaningful authority over decisions that affect rights, safety, health, employment, finance, opportunity, or human welfare. Human oversight must also be genuine. A person should have the knowledge, time, information, and authority required to question an AI recommendation. They must be able to request further evidence, reject the output, select another course of action, or stop the system when necessary. Human involvement should not become a symbolic approval at the end of an automated process. It should preserve judgment, responsibility, and control. The third takeaway is that governance must span the entire life cycle. Responsible AI begins before development. Organizations must define the legitimate purpose, decide whether AI is necessary, identify affected stakeholders, assess possible harms, and establish acceptable use boundaries. Governance must continue during data preparation and model development. Teams must examine data quality, representativeness, privacy, intellectual property, bias, accuracy, robustness, and security. Before deployment, the system must be tested under realistic conditions. Performance thresholds must be established. Responsibilities must be assigned, and escalation, fallback, override, and withdrawal procedures must be defined. After deployment, governance continues through performance monitoring, bias and drift detection, incident reporting, human review, security updates, user feedback, periodic audits, and documentation of changes. Responsible AI is not a single policy, a one-time technical test, or a final compliance approval. It is a continuous system of governance and management. The fourth takeaway is that AI value depends on more than the model itself. Purchasing a license or accessing an advanced system does not automatically create productivity or organizational value. Effective adoption depends on reliable data, appropriate infrastructure, workforce skills, secure integration, governance, and business process redesign. Organizations must determine where AI genuinely improves a workflow. They must decide which activities should be automated, which should be supported by AI, and which must remain under human control. Employees need the skills to frame problems, guide systems, evaluate outputs, protect information, identify bias, and recognize when escalation is required. The technology must be integrated into real work, not treated as an isolated experiment. Poorly selected AI projects may consume money, time, computing resources, and managerial attention without producing meaningful results. The fifth takeaway is that accountability cannot be delegated to a machine. AI may assist with decisions, it may coordinate workflows, it may access tools and enterprise systems. And increasingly capable AI agents may carry out multi-step actions with reduced supervision. But an AI system cannot accept legal responsibility. It cannot accept professional responsibility. And it cannot accept moral responsibility. People and institutions remain accountable for the system's design, deployment, monitoring, use, and consequences. Responsibilities must be clearly assigned. Records should make important decisions and actions traceable. And organizations must be prepared to correct, restrict, suspend, or withdraw a system when its risks cannot be controlled. These 5 lessons are closely connected. AI capability creates opportunity. Human oversight provides judgment. Governance establishes safeguards. Skills, data, infrastructure, and process design create value. And accountability ensures that responsibility remains where it belongs. Responsible AI is therefore the bridge between capability and trust. It allows organizations to pursue innovation while protecting people, preserving human agency, and maintaining responsibility for the outcomes. Artificial intelligence is still in its early stages. Large language models have already changed the relationship between people and computers. Natural language has become an important interface for technology, allowing professionals to access sophisticated capabilities without needing advanced programming skills. But the next wave of development is already underway. AI agents will increasingly interpret goals, gather information, plan sequences of action, use tools, and perform multi-step tasks with varying levels of human supervision. Multimodal systems will work across different forms of information. They will process and generate combinations of text, images, audio, video, numerical data, and other inputs. Autonomous workflows will connect AI capabilities across organizational processes. Systems may coordinate research, retrieve knowledge, prepare documents, analyze data, communicate with other applications, and complete parts of a workflow with less direct intervention. Intelligent knowledge platforms will help organizations bring together documents, data, experience, and institutional knowledge. They may enable people to retrieve information more quickly, identify relationships across large knowledge collections, and collaborate with specialized AI assistants and agents. These developments will expand what artificial intelligence can accomplish, but they will also increase the importance of governance. As systems gain access to more information, use more tools, and take more actions, errors may travel further and faster, privacy and security risks may increase. Accountability may become more difficult to trace, and human oversight may need to be designed into increasingly complex networks of people, systems, and agents. The future will therefore not be shaped by technical capability alone. It will be shaped by how responsibly people and intelligent systems collaborate. Organizations that focus only on automation may overlook the greater opportunity. The strongest results are likely to emerge from systems that combine complementary capabilities. AI can contribute speed, scale, computation, memory, pattern recognition, monitoring, and routine execution. Humans contribute purpose, experience, creativity, ethical reasoning, empathy, leadership, contextual understanding, and accountability. The task is not to make every process autonomous. It is to design work so that people and AI each contribute what they do best. For individuals and organizations, the most valuable investment may not be learning every new AI tool. Tools will continue to change, models will be updated, new applications will appear, and today's leading platform may eventually be replaced by something more capable. The more enduring capability will be learning how to collaborate effectively with intelligent systems. This includes knowing how to define a problem, provide useful context, evaluate evidence, verify and output, recognize limitations, protect sensitive information, and retain human judgment. It also includes knowing when AI should not be used. Future advantage will depend on people who can combine domain expertise with AI literacy, and organizations that can combine innovation with responsible governance. The objective is not a workplace dominated entirely by machines, nor is it a future in which people reject intelligent systems. The more likely path is one of collaboration. Human professionals, AI co-pilots, specialized agents, multimodal systems, and autonomous workflows will operate together within governed organizational environments. Success will depend on how thoughtfully these systems are designed, how carefully risks are managed, and how clearly responsibility is maintained. Artificial intelligence is not replacing human intelligence. It is expanding the scale, speed, and range of what human intelligence can accomplish. But that expansion must remain guided by human purpose. It must remain grounded in human values. And it must remain subject to human accountability. The future is not simply about more powerful artificial intelligence, it is about more capable human-AI collaboration, supported by responsible design, meaningful oversight, and trustworthy governance. This section follows the source paper's conclusion that responsible AI connects capability with trustworthy use, and that future value will be shaped by effective human-AI collaboration, AI agents, multimodal systems, autonomous workflows, and intelligent knowledge platforms.